Okay. Assalamualaikum, a very good day to you all. In This is continuation for the previous introduction. Okay. So you can see this topic I'm going to cover spring rates. Okay, topic 4.1. Okay, in the previous video I talk about the introduction of the chapter. Okay, now I go for 4.1 spring rates. Okay, spring rates. Okay, it's also a part of the chapter 4 deflection and stiffness. You can scan the code to get to see to watch my all my videos related to this subject matter lah, from Sydney Mechanical Engineering Design. Okay. Okay, elasticity and spring. Elasticity, what is elasticity? It's a property of materials allowing them to regain shape post deformation, meaning that the simplest thing that you can see observe with you is the rubber band. When you go to the food stall, you ask for the takeaway, they give you the takeaway with the rubber band. Okay, you expand the rubber band, and then you release your hand. The rubber band will come back to its original position. That is called elasticity. Okay, elasticity. Okay. Spring, mechanical element exerting force when deformed. There is a chapter on spring, and a chapter on spring within this textbook also. I will discuss later on. Okay, I will discuss later on. In the future, I will discuss the topic on the spring itself. Okay, the key concept of spring is force deflection relationship, is fundamental in spring mechanics. Okay, so can see here the linear spring example, deflection is directly proportional to applied force within elastic limit. For example, frame beam deflection, beam is supported at both ends, deflect proportionally under a central force. Spring constant define stiffness calculated as K equal to F over Y. Actually, what you learn in your secondary school in your physics class, F equals to KX. F equals to KX. Okay. So this is what you learn in your secondary school. Deflection is directly proportional to the applied force. Meaning that when you give load for the spring goes down, and then when you release the load, springs go up, back to its original position. This is the spring lah. Okay. So nonlinear spring behavior, and force deflection is not directly proportional. Stiffness of spring, shorter beams deflect unless under identical force, and softening springs, this require decreasing force near flatness. Okay, so this is the things about the spring. Um, it is thing about the spring. Sometime the spring, if you go the spring should when you put the load of the spring, it will go down, and then when you release the load, it will come back into its original position. Okay, some of the time, if you put excessive load, it will go up and down, not normally. It's not in normal. Okay, so this is the thing lah, nonlinear behavior. Okay. Shorter beam reflect less under identical load. Okay, the shorter the beam, spring, uh, uh, the spring function also, uh, when I talk about spring, you can imagine a spring. But now in this subject matter, behavior of this, like this, is also spring behavior. It's also spring behavior. If you put the load, this is the beam, and you put the load, it goes up and down, up and down. Okay, it also spring behavior lah. And this is what I call by spring lah. Okay. Okay, spring rate, major stiffness of a spring representing force of a unit deflection, calculating formula for F equals to KY equal accurate force deflection calculation. Unit of measurement, common unit is in pound per inch, and pounds per inch radian in angular. Okay, so and then this is the last slide of it. Okay, okay, so that's all for the video on the chapter 4.1. You can scan the code for more videos in my channel lah. Okay, that's all.